All right, so today we're going to be focusing on standard 8G7, which talks about learning and understanding and applying the Pythagorean theorem. We'll focus on using the Pythagorean theorem to figure out unknown lengths in the real world situation. We're going to focus on two-dimensional objects today, and then we'll continue with three-dimensional objects. And then after that, we'll use the Pythagorean theorem to find the distance between points within the Pythagorean theorem. To do that, we're going to do this Desmos activity. I think it's very well laid out. And as we go through, I'll talk about some of the stuff in there. So when we talk about the Pythagorean theorem, we're talking about a right angle triangle, all right? A right angle triangle with two legs. See, I already have it labeled here, two legs. And then that long side, we call it the hypotenuse. The hypotenuse is the longest side of the triangle. All right, and then the two legs are the two sides that form the right angle triangle. So we see that right angle triangle. Those two legs form the right angle triangle. So then if we connect the two ends of those legs, we get the hypotenuse, and it's the longest side of a triangle. Also realize that the hypotenuse is not connected to the right triangle at all. The right angle, sorry. So you see the hypotenuse is opposite of the right angle. So for this first activity, we're gonna grab the points, the dots, and we're gonna attach it to where we think the labeling of the triangle is. So we know that the long side that is opposite the right angle is the hypotenuse. So then we'll drag that over there. And then the short side, and then a long leg. So you have the short leg and long leg, the two legs, but one of the legs is short, one of them is long. And then the longest part is the hypotenuse. All right, we just got to remember that portion of it. So now we're going to look at what we actually mean when we talk about the hypotenuse. So I replaced the hypotenuse with the C and the legs with A and B. All right, I could put A and B wherever because they're two legs. It doesn't matter. However, I will label my hypotenuse as C. So we're talking about the Pythagorean theorem. Again, we're talking about these three sides. Go ahead and write this down as well. Okay, and then in this first part, it states that the Pythagorean theorem in a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. I'm actually intrigued to find out or see how would you write an equation to resemble what this is saying. So this right here is in words. I want you to send me your responses as to how you would write this as an equation. It says the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. How would you write this? I'm interested to figure out how would you write this as an equation. So let's go back and look at this right here. So it says the sum of the squares of the legs. So I'm summing or adding the squares of the legs, which is A and B, is equal to C squared. So that is our Pythagorean theorem. All right, we'll go through proofs of the Pythagorean theorem. But for now, this is the equation from what we had talked about before. So if we're trying to find a specific side, for example, if I say C is 12 and A is 11, I'm going to put that into my equation. I'm going to solve it out. Obviously, I'm going to have to find what B is. All right, so we've already been through, we know how to solve these. All right, when it comes to doing the additive inverse, the square root, whatever that is, we'll put that number in and then we'll solve for whatever variable that we need to. So with that said, let's go ahead and do this one. Let me see how you would solve this one. So it says, I'm trying to find what C is, right? It says A is 3, whichever, and B is 4. I put those in, I need to find what C is. So the question asked me to find what c is. So I'm going to go ahead and write my theorem. A squared plus b squared equals c squared. I have a, so I'm going to do 3 squared. And I have b, so I'm going to do 4 squared. Equals to c squared. The goal is to find c. So 9 plus 16 is equal to c squared. 9 plus 16 is 25. So 25 is equal to c squared. They didn't ask me to find c squared. They asked me to find c. So in order to find c, I need to square root it so that the square could be taken out. But whatever I do to one side, sure enough, got to do it on the other side. So c, so square root of 25 is 5, is equal to c. c is equal to 5. So right here is equal to 5. Or I could just replace this right here to equal to 5. And that's how I would solve. So I just work it going all the way down until I figure out what c is. So now we're going to talk about the converse. We're talking about the converse of the Pythagorean theorem. It's talking about in a triangle, the sum of the squares of the two shortest sides is equal to the square of the longest side. The triangle is the right triangle. We've already talked about it, and I'm going to give you an example of what that is. Again, you could use the Pythagorean theorem to figure out if it's a right angle triangle. All right. So if the sides don't even match up, then you know it is not a Pythagorean theorem. It's not a right angle triangle. What if I gave you a triangle that looks like this? And I say that this is 5. This is 4. This is B. And I said solve for B. So I already know my Pythagorean theorem says a squared plus b squared equals to 90. It's not 90, c squared, sorry. It's equal to it. It's not lesser than or greater than. It's equal to. If it's lesser or greater than, you know it's not a right angle triangle. All right, so I know a squared is 4. I don't know what b squared is. And I know c is 5. So it's going to be 5 squared, right? So then now I'm going to have 16 plus b squared equals 25. I'm going to do my additive inverse, get 16 away. So b squared is equal to 9. Now I have to square root both sides. So b is equal to 3. So then I could say that this right here is 3. But if I want to check really, we talk about showing that this is a right angle triangle. I do 3 squared plus 4 squared, right? Equals 5 squared. This should hold true. 3 squared is 9 plus 16, and this is 25. 9 plus 16 is 25. So 25 is equal to 25, which means this is a right angle triangle. Okay, I just wanted to go through that so you see what I'm talking about. Now we're going to go through and finish one last activity, but let me know if you have questions about this.